Hi viewers, myself Indumati, Assistant Professor, Mechatronics Engineering, K.S.Rangasamy College of Technology, here to present you the topic of SCADA systems under the subject of Industrial Automation Protocols. Let us get into the topic. First of all, let us note the definition of SCADA. SCADA, it is nothing but a supervisory control and data acquisition, and it is a category of software applications for controlling different industrial processes, which is the gathering of data in real time from remote locations in order to control equipment and conditions. SCADA provides organizations with the tools needed to make and deploy data-driven decisions regarding their industrial processes. Suppose in large plants and large industries, if we need connect all the real-time data acquisition under the single supervisory control computer system means we need SCADA systems to monitor everything data acquisition systems in the real-time monitoring systems. So one of the most common used types of SCADA is industrial control system. SCADA can be used to manage almost any type of industrial processes. SCADA systems include hardware and software components. The hardware gathers and feeds data into field controller systems, which forward the data to other systems that processes present to a human-machine interface in a timely manner. Their human-machine interface is nothing but the monitor or a display which connects the human to the machine, where immediate connections, anything can be shared through this human machine interface. SCADA systems also record and log all events for reporting processes, status and issues. If any malfunctioning is there, any occurring in the SCADA system means immediately the logging process, alarm logging concept is in the SCADA systems. Immediately the alarm logging process will immediately record its issue, date and time, everything in the SCADA systems, and that can be monitored through the SCADA applications. And SCADA applications warn when conditions become hazardous by sounding alarms. SCADA systems, what are the components which are included by the SCADA systems? So let us see now. SCADA system include components deployed in the field to gather real-time data, so as well as related systems to enable data collection and enhance industrial automation. SCADA components includes sensors and actuators. Why we are include sensor and actuator means actually the inputs to the SCADA systems, that is data acquisition inputs, are gathered through sensors and actuators only. For example, if we need to monitor the temperature of a particular room means we are having temperature sensors to detect the temperature range, and the same temperature, the real-time temperature data acquisition is given to the SCADA system as an input here. So this is how we are using sensors and actuators as a input for detecting the inputs of the industrial processes. Actually, actuator is a feature of the device or system that controls the mechanism of the process. So a sensor functions like a gauge or a meter which displays the status of your machine. An actuator acts like a switch, dial or control valve that can be used to control a device. Both sensors and actuators are controlled and monitored by SCADA field controllers. Next important components is SCADA field controllers. These interface directly with sensors and actuators. There are two categories of field controllers. One is remote telemetry units, RTUs. Generally, we are calling it as RTUs in SCADA systems, which interface the sensors to collect telemetry data and forward it to a primary system for further action. So if the data acquisition systems are in the remote units, the SCADA supervisory system is distance apart from the field controllers means we can connect it through the remote telemetry units. So this is the purpose of RTUs. And programmable logic controllers, which interface the actuators to control industrial processes, usually based on current telemetry collected by RTUs and the standard set for the processes. Next one is SCADA supervisory computer. These control all SCADA processes and are used to gather data from all input devices and send commands to those devices to control industrial processes very effectively. So actually the inputs are getting from the sensors and actuators. After that, the field controllers are used for controlling the interface between supervisory control and the field. For that, we are using remote telemetry units and programmable logic controllers. Later on, we are connecting it to the SCADA supervisory computer, which is like master of controlling all the devices. Next one is HMI software. This provides a system that consolidates and presents data from SCADA field devices and enables operators to understand and, if needed, modify the status of SCADA controlled processes. Communication infrastructure. This enables SCADA supervisory system to communicate with field devices and field controllers. This infrastructure enables SCADA systems to collect data from different field devices and control these devices. Actually, to understand the SCADA effectively, let us take the classroom itself. Actually, the classroom itself, we are having some 60 number of students, means each and every 60 number of students are having different data, name, roll number or register number or their address, whatever it may be, different data. And those data are each and every student are having those data, and they are supervised by one team leader as a class representative. He is the PLC. He will monitor everything. And the master supervising computer is the professor which are taking the class or teacher which are taking the class. He is like acting as a SCADA, supervisory computer. And likewise, the SCADA will act inside the industrial plant to control everything automatically inside the field controller, input devices and output devices and actuators and sensors. So to control everything, they are using PLC. PLC is like a class representative, and those PLCs are controlled by the master supervisory system, that is like teacher in the classroom. So this is a simple understanding for SCADA systems. And what are the features of SCADA system means? Data acquisition. It is a foundation of SCADA systems. Sensors collect data and deliver it to field controllers, which in turn feed data to the SCADA computers. Then remote control. This is achieved by control of field actuators based on the data acquired from field sensors. Networked data communication. Here we can use any type of networked data communication. We can use LAN and wide area networks. Also, we can use Ethernet cables. Also, we can use even IoT, industrial IoT also can be possible for SCADA connections nowadays. And data presentation, which is achieved through the HMIs, which represent current and historical data to the operators running the SCADA system. Real-time historical data are both important parts of the SCADA system, as they enable users to track current performance against historical trends. Alarms alert SCADA operators to potentially significant conditions in the system. If any malfunctioning occurs, means immediately alarm get started, and we need to be stopped, started or adjusted, whatever may be happened inside the field. And reporting on SCADA system operations can include reports on system status, process, performance, and reports customized to specific users. Layers of the SCADA system. Layers of the SCADA system, the level 0 field level control. Field level control includes plant. These plant having sensors, actuators. So basic field level control is nothing but initial. That is, each and every student is like a field level control. That is, we are taking input from basic sensors and actuators of the particular plant. Then the same sensors and actuators are connected to the level 1 direct control. Direct control is nothing but RTU, RTU and PLCs, remote telemetry units and PLCs. Then next level is supervisory control. Supervisory control is nothing but SCADA computers. So immediately the PLC and RTUs are connected to the SCADA computers, which are directly connected to the RTU and PLC. So the PLC and RTUs are controlled by the SCADA computer. Like this is each and every student in the classroom. This is the team bench leader in the classroom. So the each and every bench leader is monitored by the class representative, and the level 4 is nothing but production control. Sorry, level 3 is nothing but production control. This production control is system-wide SCADA supervisory computer. This control is system-wise supervisory computer are monitored by the SCADA computers. And finally, the production scheduling. The production scheduling is the master computer center where the SCADA computer centers are available. These are all the layers of the computer center. This may be head of the department or any headmaster of the school or principal of the department, whatever it may be. So the basic is plant, and this is connected through the RTU and PLCs. And finally, this is monitored by the SCADA computer. Then system-wise SCADA supervisory computer and SCADA computer architecture. So the level 0, the fleet level includes sensors and actuators. Then level 1, the field level controllers includes PLCs or RTUs. And level 2, the plant supervisory level includes local supervisory systems which aggregate data from level controllers and issue commands for those controllers to carry out. And the production level control which includes system-wide supervisory systems that aggregate data from level 2 systems to produce ongoing report to the production scheduling level. Level 4, the production scheduling level includes business systems used to manage ongoing processes. So, hope viewers can get the basic introduction to SCADA systems, get the knowledge, KT, about basic of SCADA systems. Hope you are understanding well. Thanks for watching. Keep learning and keep growing. This is signing off, Indumati, Assistant Professor, Mechatronics Engineering from K.S.Rangasamy College of Technology. Thanks for watching. If you have any comments, please post it in the comment box and give likes for my video. Thank you.